All right, guys. So we're doing really well. So the previous question, guys, BMAT 2015, question 18. We were looking at just ideas of just general ideas of kinetics and how they apply to this following reaction. Now, guys, we're going to move on to the next question, BMAT 2014, question 6. This is which row in the table correctly explains why an increase in temperature increases the rate of reaction. So, guys, pause the video. Make sure you're back after a minute, and we're going to go through the solution. All right, guys, so welcome back. So increasing temperature. So let's look at the first thing. Does an increased temperature have an effect on the activation energy? No. So remember, activation energy is only affected by the presence of a catalyst. So this should be no effect. So it can either be this option, it can be this option, or it could be this option. Effect on collision frequency between particles. So remember, as you increase temperature, particles have more kinetic energy, and therefore they're going to collide more frequently, isn't it? So this should increase. So this should increase. So it's either going to be C or H, and an effect on proportion of collisions which are successful. Yeah. So clearly, guys, also this is also good. If you have more collisions, you're inevitably going to have more successful collisions, and also on top of that, remember, if you remember back to your Maxwell-Boltzmann. So remember your Maxwell-Boltzmann distribution, which gives basically the number of molecules with a particular type of energy. Remember, on the x-axis you have energy, and on the y-axis you have number of molecules. And then the graph was somewhat like that, and then it asymptotes. So remember, what happens is that when you increase the temperature in the reaction, the curve shifts like that. And remember, this is the activation energy, right? So then, can you see there's this extra area, right? Which that extra area is basically, it basically puts forward the fact that you have an increase in proportion of the number of molecules which have successful collisions. So that means that this should also increase. So that means, guys, that the answer we're going to get over here is H. So hopefully, guys, that has made sense. And as always, we look forward to seeing you in the next video. All right, guys, so welcome back. So previously looking at BMAT 2014, question 6, talking about what an increased temperature does to basically the rate of reaction and the mechanism through which it increases the rate of reaction. But now, guys, we're going to move on to the next question, BMAT 2012, question 26. There's a mixture of C2H4 and H2 are placed in a sealed container. Some finely divided nickel is added as a catalyst to the mixture. The temperature rises to 150 degrees and the two gases slowly react to give C2H6. And says, which row of the table correctly identify how the pressure changes after the nickel is added? So, guys, pause the video, give yourself a minute, be sure to be back after the minute, where we're then going to go through the solution. Okay, guys, so let's go through this. So, what essentially we have here is that the reaction we have is ethene reacting with hydrogen to produce ethane, C2H6. And remember, this is essentially a hydrogenation reaction, which is going to be catalyzed by nickel, which is finely divided in this reaction. And then it says the temperature rises to 150, and the two things react. And then it says, what are the pressure changes? So essentially, guys, as you can see here, you're going from essentially two molecules to one molecule, right? Remember, pressure is pressure basically depends on how many things you have, essentially. So in this reaction, over the course of this reaction, you're going to end up with less things, essentially, right? So since you end up with less things, that means through the course of the reaction, your pressure should be decreasing. So that means that during the course of the reaction, it should be either B, or it could be this one as well. It could either be E as well, okay? And then the next thing it says, initially the temperature is high, right? So since the temperature is high initially in the reaction, the particles are going to be banging on everywhere, banging on the walls of the container, and that's initially going to give you a high pressure in the reaction. So that means initially it would increase. That means that the answer we should get here is E. So hopefully, guys, that has made sense. And as always, we look forward to seeing you in the next video. All right, guys, so welcome back. So previously you were looking at BMAT 2012, question 26. Hopefully, guys, that question has made sense. And, this idea of how pressure works also makes sense. But if you have any questions regarding that, guys, just comment down below and we can address those. So the next question, guys, is BMAT 2011, question 6. It says, when molecules collide for a reaction to take place, two conditions must be met. Firstly, they must have sufficient energy to react, and secondly, they must have the right orientation. This means that the ends of the molecules that are going to react must be in contact with each other. Raising the temperature speeds up a chemical reaction. Which of the following could be responsible for this? And then you have three options. So guys, pause the video, give yourself a minute, be sure to be back after that, and then we're going to go through the solution. All right, guys, so let's go through this. So your increase in temperature. So number one, is there going to be more collisions? Yes, because as it increases temperature, the particles have more kinetic energy, and if they have more kinetic energy, they're flying around more, and they're more likely to meet another molecule and therefore collide. So you get more collisions. Number two, the average collision has more energy. So remember back to, I think it was 2 questions back when we were looking at the Maxwell-Boltzmann. Remember, you have the shift, which means more collisions are greater than the activation energy. So the collisions are going to have more, average energy of the collision is going to be higher. So this is also true. And 3, the orientation of the molecule is more favorable. If anything, think about it, guys. If you increase the temperature and things are moving around more crazily, if anything, the orientation is going to be less favorable, right? So it can't be 3. So that means that the options we're going to have, guys, is 1 and 2, and therefore D should be our winner. D should be the correct answer. So hopefully, guys, that has made sense. And as always, we really look forward to seeing you in the next video.